Welcome. My name is Andy Pokshavinsky, and I'm a science teacher at the Lower Kuskokwim School District. I'd like to share with you how I introduce a unit with phenomena. And in this case, the question I'm going to ask students to begin with is, what is everything made of? We're beginning a unit on the cycling of matter in biology, where we're going to take a look at biomolecules. And I'd like to dive into this piece of matter that is a blueberry. This is a connection that I'm making to one of our science standards for Alaska that have been published since June of 2019. They're based on the framework for K-12 science education. So the question is, what is a blueberry made of? What are biomolecules? Our standard asks students to construct and revise an explanation based on evidence for how carbon, hydrogen, and oxygen from sugar molecules may combine with other elements to form amino acids and or other large carbon-based molecules. So what are these biomolecules? How can we use phenomena to connect students to this particular performance standard? I'm going to share with you how I do this through a video called What is Everything Made of? Now you'll hear me drawing some connections to what the students have learned in previous classes, physical science, on atoms. I'm going to ask the students or remind the students that atoms and molecules are similar, but they're different. And molecules are a combination or a bonding of atoms to make molecules. And that is the process that happens in the creation of biomolecules. And we'll have to review some vocabulary such as atoms, molecule and compound, and even things such as how we write the chemical formulas. So the terms scientists use for matter are an important background information, and I'm going to use those in this phenomena introduction. And I'm also going to introduce my students to this idea of how many bonds do different types of elements that make up living things make, as we look for patterns in these molecules. So I'm going to share this with you, and I hope you enjoy how I introduce this to students to hook them into our lesson on biomolecules. Sometimes when I'm picking berries, I have these crazy questions that come to my mind. What is everything made of? What is a blueberry made of? If you blew up a blueberry and you tore it apart and you kept tearing it down further and further, you would eventually come up with an atom of carbon. Carbon is an element and an atom. Everything in the world is made up of these atoms. Matter is made up of atoms. Perhaps you remember this from physical science. And there are lots of different types of matter. In fact, we can look at the periodic table and we can see that there are 90 to 100 different types of atoms. But living things are made of four main types of atoms we call elements. And those elements are carbon, hydrogen, oxygen, and nitrogen. And yes, we do have some phosphorus, and sometimes they call it carbon, hydrogen, oxygen, nitrogen, phosphorus. But we're going to focus on the four main types of atoms, which are elements. Okay, so there's carbon, there's hydrogen, there's oxygen, and if we broke a blueberry apart, we would find these little teeny atoms of carbon and hydrogen and oxygen and nitrogen making up everything. Well, let's start simply by looking at the simplest element. It's the first element on the periodic table, and it's called hydrogen. And an element is made of a positive particle called a proton inside of a nucleus. It also has a neutron inside of that nucleus, but on the outside of that nucleus there is an electron that orbits around the nucleus. And that electron is really lonely because it doesn't have a buddy like the proton has a buddy. It has the neutron in the middle. But this single solitary electron wants to pair up with a buddy. So it tries to find another atom with a lonely electron, like this additional hydrogen atom that I'm going to build over there, and these two lonely electrons come together to form what we call H2, and they form a chemical bond. Chemical bonds are made when electrons, atoms share electrons, and because they're sharing those electrons, they stick together. And so when we look at living things, we are looking at bonds between the four major biology elements, these carbon, hydrogen, oxygen, and nitrogen. And we look at chemical bonds that form between carbon, hydrogen, oxygen, and nitrogen. And if you look at carbon, it can form 4 bonds, and we'll show you a little bit more about that. If you look at hydrogen, it can form 1 bond, oxygen forms 2, and nitrogen forms 3. So let's take a look at this carbon atom a little bit. As we build it, it has 6 protons, 6 neutrons, and to start with, it has 2 electrons in its outer shell. But those electrons are, they're happy because they're together, they're bonded, so they go down to that lower shell. And then in the outer shell, we have 4 lonely electrons. So they want to make bonds. Carbon likes to bond with 4 other molecules or atoms. I have to keep this straight. And you can see that we can bring 4 hydrogen in, and the lonely pair of electrons, or the single lonely electron in the hydrogens, pairs with the 4 lonely electrons in the carbon, and then they're very happy and they form something called methane, or CH4. And so there's different ways of modeling these atoms. And you can see that you can write the name of the element, and we can build the actual model with the protons and the neutrons and the electrons. But to keep things simple, as we look at biomolecules in biology, you're going to see a model that might look a little bit like this. It's a C, which is the chemical or symbol for carbon. And I put a little hint on here for you. There are 4 dashes, which means carbon can make 4 chemical bonds because it has 4 lonely electrons. Notice as I add the hydrogen that the hydrogen only has 1 dash. Hydrogen only has 1 lonely electron, so it only bonds with 1 other atom. And as we are making these bonds, we can build a molecule or a compound. So molecule and compound are the same word, and that molecule or compound can have a chemical formula, which is CH4, which means 1 carbon. If you don't see a number, it means 1, and 4 hydrogen. That compound is methane, and methane is the gas that you fart out when you fart. That it smells kind of like a nuck, right? So that's methane, and it's an organic molecule. But let's go back to our blueberry. So our blueberry is made of atoms. These atoms bond to form molecules.
And these molecules are everywhere. Water comes from the sky, it falls into the tundra, and blueberries absorb water. They rearrange those chemical bonds to form sugars that make blueberries taste so good. The air is full of molecules. These molecules are absorbed by plants, and the plants then produce molecules, rearrange those atoms to form our unique blueberries. So I hope that as we study biology, you will keep this question in mind. What is matter? And how does matter get rearranged to form a living thing as wonderful as a blueberry?
So once I've used this anchoring phenomena with my students, we do an inquiry cube activity. I introduce them to a simple inquiry cube at the beginning of our course, and now we're going to apply that same kind of pattern recognition to an inquiry cube that has different types of biomolecules. On one side it has proteins, there's nucleotides, there's carbohydrates, and I'm challenging my students to start to look for the patterns in the arrangements of the carbon, hydrogen, oxygen, and nitrogen elements that make up everything that is living. And we continue on digging into different scaffolds that help us with this pattern recognition. And there's a couple of different strategies. And if you're wondering where I got these strategies, I'd like to share this resource with you. This is the Patterns Biology website, and it's a really great model of how to apply three-dimensional learning using the Alaska Science Standards. And so if you take a look at how the unit is organized, here you'll see the Alaska Science Standard, and it's labeled the same way it is in our standards in this lesson plan. You might see some other references as well, but they crosswalk very nicely with our standards. And as you read into the unit itself, you can see the inquiry cube activity. There's a slideshow that you can follow up with that conversation, and some additional pattern matching activities, because the cross-cutting concept for this lesson is patterns, and you can see that coded over here in green. You can also see that the science and engineering practice is constructing explanations. And then finally in orange, you see our disciplinary core idea. And there's all sorts of helpful links for you as a teacher to begin to orchestrate this three-dimensional learning after you've introduced your phenomena. I hope you've gained some insights into how to introduce a unit using phenomena and some of the strategies for weaving in three-dimensional learning with our new science standards for Alaska. Thank you.